In this video, we'll talk about determinants 2 by 2 and 3 by 3. So let's start with 2 by 2. If we have a determinant with 2 lines and 2 columns like we have here, we write it in this form, A, B, C, D. And to compute it, all we do is we multiply the terms on the main diagonal, so AD minus, and then we multiply the terms on the second diagonal, BC. So it's always AD minus BC. So for example, if we have negative 1, 3, 2, 4, for example, we solve it this way. We multiply these two together. So it's negative 1 times 4 minus, and now we multiply these two together. 2 times 3. So we get negative 4 minus 6, which is negative 10. So 2 by 2 determinants formula is very important because it comes up in even 3 by 3 and 4 by 4 and so on. Now, to calculate 3 by 3 determinants, which in general would look like A, B, C, D, F, G, H, I, where we have like 3 rows and 3 columns, and we have more than one method. So I'm going to discuss these two methods, Sarus method and expansion by minors or cofactors, or the general formula, the one that it's usually used. So the Sarus method, what it involves is we copy again AD, and I should copy them with a different color. We copy ADG, we copy the first and the second column, and now we multiply the terms from the first diagonal, so we get AEI, and then plus, and we multiply all the other columns that are, or all the other diagonals that are parallel to this one. So basically BFG plus CDH minus, that's minus from the definition, and now we do the same with the secondary diagonal, which is CEG, and all the other ones that are parallel to it. So CEG plus AFH plus BDI. So all you have to do once you have numbers in here, you actually open up the parentheses and you compute that. Now this method can also be written this way. So A, B, C, D, E, F, and G, H, I, sometimes people copy the first two rows instead of the first two columns, and we do the same thing. So we have the main diagonal and then parallel to it. So we will get AEI plus DHC plus GBF minus, and now we copy the secondary diagonal, which is CEG, FHA, and IBD. So basically CEG plus FHA plus IBD. And if we compare these two, let's see. Do we get exactly the same terms? Let's see, BFG. BFG is just the terms the factors are written in a different order. CEG, CEG, but then AFH and FHA. But multiplication is commutative, so no problem here. So let's see an example. So I want to solve this example, and I'm going to use Sarus method. And I prefer to use it by rewriting the first two rows, so I'm going to do just that. And now, it's the main diagonal, 2 times negative 1 times negative 1, it's times here, plus, and then parallel to it, 1 times 1 times 3, plus 0 times 0 times 4, minus, and let's get the other terms, 3 negative 1, 0, and parallel to it. So 3 times negative 1 times 0 plus 4 times 1 times 2 plus negative 1 times 0 times 1. So let's do the multiplication. This one is 2, this one is 3, this one is 0, minus this term is 0, 8, and this term is 0. So we get 5 minus 8, which is negative 3. And we compute it using Saro's method. Now another method to calculate determinants of 3 by 3 is using these minors or cofactors. And what we are actually doing, we are expanding by a row or a column. So let's say we want to expand by a row. So we'll consider this row, and this is what we're going to do. Let's take the first term, which is a, times, and now we imaginary or even like physically, we cross out the row and the column of a, and we end up with the determinant of t 2 by 2, E, F, H, I. Then we get the next term, which is minus b times. So this minus is from definition, or if you want, we can say this term has negative 1, 2, 1 plus 1, because it's first column, first row, so that's why it's plus here. While this one is negative 1, 2, first column, second, first row, second column, so that's a negative, that's why we have minus b. And now again, we cross out the row and the column of b, so we get d, f, g, I. And then plus, and why it's plus? Because it's negative 1 to first row and third column, which makes it negative 1 to the fourth, which is positive. And so C times, and the determinant that it's obtained when we cross out, D, E, G, H. A common mistake that I notice students do, they forget to put this A, B, and C, which are exactly the numbers that we get from expanding by row. We can do also expansion by the column. So you would have A times whatever is left when you cross out, then minus D, whatever is left when you cross it out, and then G times the determinant that is left. And each determinant, it's a 2 by 2, so it's easy to compute. So let's do an example. So we have to calculate this example. I'm going to expand it by the first row. So it's going to be 1 times, and then when we cross out the row of 1, we get 2, negative 1, 4, 1. Then minus, so we are expanding by this. Then 2 times the determinant that it's obtained when we cross the row and the column, it's 0, negative 1, negative 2, 1. And then plus 0 times the determinant, 0, 2, negative 2, 4. So we get 1 times, and then we multiply these two, and then we multiply these two, so we get 2 times 1 minus 4 times negative 1, minus 2 times 0 times 1 minus negative 1 times negative 2, plus 0. I don't even have to calculate the determinant because 0 times number is going to be 0. So we get 1 times 2 plus 4 minus 2 times negative 2. So we get 6 plus 4 equals 10. And we calculated determinants of 2 by 2 and 3 by 3. Now, this one, the expansion by minors, cofactors, or general method that it's used, it's good because it's easy to use for a 4 by 4 or a 5 by 5 because we are always breaking down into smaller determinants, which we can calculate faster. I hope this helps.